Hello viewers, I'm Kausalya. Today we are going to solve problems in exercise 10.2. Problem number 5. Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. That is, so here the thing is little bit reverse, right? You see, anyway we are having a tangent and there is a circle, right? So just draw a circle and draw a tangent, right? So here you see, prove that the perpendicular at the point of contact to the tangent. So what is the perpendicular? This is the part that will be perpendicular because only this radius and tangent are said to be perpendicular to each other, right? So perpendicular at the point of contact to the tangent, right? It passes through the center. We have to prove that this perpendicular line from the circle, right, it passes through the center of the circle. We have to prove. Can you get the question? We are having a circle and there is a tangent, right, and there is a perpendicular line, okay, and we have to prove that this perpendicular line should pass through the center, right? So here you see, here we have to draw the diagram by ourselves, right? So AB is a tangent with center O and R is the radius. And P is the point of contact, okay? P is the point of contact here. Now, in order to prove that, we are considering, you see, we are considering a point D somewhere around here, right? And we are connecting this D to the P. Now, you see, let PD be perpendicular to the tangent AB at point P. Okay, we are considering by ourselves because we have to prove, right? So we are taking a point D, right? And we are connecting this D to the point P. And finally here we are making a proof. We are going to, we are just simply telling this PD is perpendicular to the tangent AB again at the point P, right? So now we have to prove that PD passes through the center O, right? So when you look at this diagram, we can say, right, is this PD perpendicular to this tangent? No, right, because you see it is little bit slanting. Whenever we are saying it as perpendicular, it should form a perfect L shape like this. Okay, here it is perpendicular and again we can say this part also perpendicular. But here the line is slanting, so just in order to prove that, we are taking a point D like this, right? So you see, OPB is equal to 90 degrees. So it is evident, right? OPB is 90, but here we are considering that DP is also perpendicular. Therefore, here we are again writing DPB is equal to 90 degrees. Actually, this is wrong, but since we have to prove, we are writing it. Okay, DPB is 90 degree. So, you see in the right hand side, we are having 90 degrees. Therefore, we can write this angle is equal to this angle. So, angle OPB is equal to angle DPB. So, which is impossible. Why? You see, it is evident, right? OPB is equal to DPB. It is not at all possible. Why? Because you see, this DPB is a part of the angle OPB, right? That is, OPB can be written as OPD plus DPB. Even we can include that also, you see. OPB is nothing but OPD plus DPB. Then how can we tell OPB is equal to DPB? It's not at all possible. So you see, finally we are writing it as DPB is a part of OPB, therefore they can't be equal. So the only way is D should coincide with O. That is, in order to be perpendicular, okay, in order to be perpendicular to this tangent, this D should coincide with O. That is, this point should be moved over here. This is the only way to make this line perpendicular. This line DP perpendicular to AB. That is the only thing. We have to move this point D to the point O. Right. Problem number 6. The length of a tangent from a point A at a distance 5 cm from the center of the circle is 4 cm. So find the radius of the circle. So again here we are having a circle, we are having a tangent. Right. So be clear. Right. You see the length of the tangent from a point A is 4 cm. Right. So A and C is the tangent, it is 4 cm. You see. And this point A is at a distance of 5 cm from the center of the circle. So from this point A to the center of the circle, the distance is 5 centimeters. Right. So beware of the question. Now we have to find the radius. Right. So obviously, what is the angle made by this between your radius and this tangent? So here it is 90 degrees. Right. As per your theorem. So since it is 90 degrees, so this is a right angle triangle. So in this right angle triangle, we know the value of these two sides. So we have to find the value of the unknown side. So what is the rule? So here we have to use our Pythagoras theorem. So what is the hypotenuse? The side which is opposite to this 90 degree is the hypotenuse. So here the hypotenuse is AB square. So AB square is equal to BC square plus CA square. Right. AB square is equal to BC square plus CA square or AC square. So what is the unknown thing here? We need to find this BC. Right. So just rearrange the expression. So BC square is nothing but AB square minus AC square. We know the value of AB and AC. So just substitute. So 25 minus 16 gives you 9. So BC square is 9. Therefore we have to find BC. So square root of 9 is 3. Therefore the radius of the circle is 3 centimeter. So problem number 7. Two concentric circles are of radii 5 cm and 3 cm. Find the lengths of the chord of the larger circle which touches the smaller circle. So here we are having two concentric circles. What do you mean by two concentric circles? Circles having the same center but with a different radius. Right. So in this case, you see, radius of the circles are 5 and 3. So the radius of the inner circle will be 3 and radius of this outer circle will be 5. Right. Yes. Now we have to find the length of the chord. What do you mean by chord? A chord is nothing but a line, right, which touches the circle at two different points. So here this is the chord, and even you can draw a line like this. This is also a chord. This is also a chord. Okay, everything is chord. If a line touches the circle at two different points, then that is known as chord. So here, find the length of the chord of the larger circle. So this is your larger circle, and to this larger circle, we are having a chord. Right. So, and that chord touches the smaller circle. Okay. So this is the chord and this chord touches the smaller circle. Find the length of the chord. You have to find the length of this part. Right. So the same diagram I have drawn here. Right. So this is the radius of the smaller circle. So it is 3. And this is the radius of the bigger circle, which is 5. And this is the chord. Right. So here you see we have to draw the diagram by ourselves. Right. So AB is the chord of the larger circle which touches the smaller circle at point P. That should be point of contact, right? So here at point P. So just for our analysis, we are joining OA and OP, right? What about the angle here? OPA. Again, it is the angle between the radius and a tangent. So here it is 90 degree, right? For this bigger circle, this is a chord. But when you omit this bigger circle, this is a tangent, right? This is AB is a tangent to this circle, to the small circle. So the angle OPA is equal to 90 degrees, right? So since this is a 90 degree, you see this triangle is a right angle triangle. So just write down the things, whatever we have said, right? OPA equal to 90 degree because the reason is the tangent at any point of the circle is perpendicular to the radius through the point of contact, right? So in right angle triangle AOP, now we are going to consider this AOP, right? What is the hypotenuse? Here OA is the hypotenuse. So OA square is equal to OP square plus AP square. So just write it down, right? We need to find AP. So AP square is nothing but OA square minus OP square. So just substitute the values. So 25 minus 9 gives you 16. So AP square is 16. Therefore AP is 4 centimeter. Right. So you see, when you observe carefully, this line OP divides the chord AB equally. Right. So already we have solved problem related to this. That is, this perpendicular will always divide this chord equally. Right. So here the value of AP is 4, right? So what about the value of PB? It will be automatically 4 because this line AB is equally divided by this radius at point P, right? Therefore, the length AB will be 4 plus 4, which is 8, right? So the same thing here, you see, AB is nothing but 2 times of AP, right? It's up to you. You can solve like this, or you can write AP plus PB is equal to AB. Since both are equal, we can write 4 plus 4 equal to 8. So here AP is 2 times of AB is 2 times of AP. Therefore 2 into 4 is 8 centimeter. Therefore the length of the chord is 8 centimeter. Right. The next problem is problem number 8. A quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD is equal to AD plus BC. So here, a quadrilateral ABCD is drawn to circumscribe a circle, right? So here the diagram is given. We are having a circle, right? And ABCD is the quadrilateral. Okay, any four-sided figure is known as quadrilateral. So here we have to prove AB plus CD, okay? AB plus CD is equal to AD plus BC, right? So here we are having some other points. They are P, Q, R and S, right? So here the first step is the tangents drawn from the external point to a circle are equal, right? So here you see AP is a tangent. Similarly, AS is a tangent and A is some other point. Okay, it is an external point, obviously. So we can write AP is equal to AS, right? Similarly, BP is equal to BQ because B is an external point and BQ and BP are the tangents. And C is an external point and CR and CQ are the tangents. And here D is the external point where DR and DS are the tangents, right? They are equal. So here we can write, you see AP is equal to AS. Similarly, BP is equal to BQ. And here CR is equal to CQ. And finally, DR is equal to DS, right? So just make a note of it. Now here we are going to add all these four equations, right? So when you add, we are adding the left hand side terms together, which is equal to right hand side terms together. So AP plus PB plus CR plus DR is equal to AS plus BQ plus CQ plus DS, right? So AP plus BP, again look back at the diagram, right? AP plus BP, which is nothing but AB, right? So you can replace this AP plus PB as AB, and similarly CR plus DR. So CR plus DR is nothing but CD. So here it is CD, right? So which is equal to, again in this case I am just combining the terms. That is, I am writing AS and DS together and BQ and CQ together. So AS plus DS is nothing but AS plus DS is nothing but AD, right? And similarly, BQ plus CQ is nothing but BC, right? So AS plus DS is AD and BQ plus CQ is BC. So finally, this is the thing what we have to prove, right? Check, you see, AB plus CD is equal to AD plus BC. So here we are finally having the same expression. Therefore, we have proved this, right? That's all. If you have any doubt, let me know in the comment section. Thank you.